So for this video, I want to try out a few questions on displacement time graphs. We're going to look at the simpler ones here, and then we'll look at the more complicated ones in a later video. Anyway, let's begin. So I've got the question here. Bob leaves his home and heads north at a constant speed of 3 meters per second for 10 seconds. We want a displacement time graph. Now this graph I've drawn would be wrong. Why would it be wrong? Because for displacement, you could be right there, somewhere at home. Maybe at home. If you are 50 meters at the front of your home, you'd be at a certain location, A. But someone could also be 50 minutes away, backwards, in the opposite direction. That would be a totally different position. You'd have to have a different place. So when we draw displacement time graphs, we need to show that. And how do we show that? Basically, we make sure that the graph goes below the x-axis, so it's going to be something like that. Now for this question, we have Bob leaves his home and heads north at a constant speed of 3 meters per second for 10 seconds. So now we have our graph properly drawn, and let's see what we need to do next. We're going to label that 0, like that. There we go. We could take the north as the positive direction. So if he's going north, he should be this side, and if he's going south, he should be going in that direction. And maybe we can take home as the 0 point. So if he's starting out at home at time 0 at the start point, he should be right there, just resting at home. So we can start drawing this. So displacement, we need to figure out the displacement. We've got the speed, so we're going to use the SUVAT equation. So S-U-V-A-T, SUVAT. So Bob leaves his home and heads north at a constant speed of 3 meters per second for 10 seconds. So we've got 10 seconds. And we've got constant speed. What does constant speed tell us? Constant speed, if the speed is not changing, that must mean that there is no acceleration, because acceleration means change in speed. So acceleration will be 0. Then 3 meters per second will actually be the initial velocity. That's the speed that he leaves home with. But in addition, because his speed is not changing, his final velocity should also be 3. Because if it's constant, at the start of the 10 seconds it will be 3, but at the end of the 10 seconds it should also be 3. Okay, so now we can figure out the displacement. We can use any equation we want. I think we can use S equals ut plus a half at squared. So that will be u is 3, t is 10, plus a half times acceleration is 0 times the time is 10 squared. Now if you've got a half times 10 times 0, a half times 0 times 10, what would that give you? That would give you a 0, so you can just cancel that whole thing out and just remain with displacement is 3 times 10. So displacement is equal to 30, to be 30 meters if we put in the units. And so now that we have the units, we can go back to our graph and sketch it. How do we sketch a graph that has constant speed? Now we might be tempted to do something that looks like this, and then put the 30 right there. Yeah, the displacement is, we figured out that the final displacement is 30, but this will not be correct. Why not? Because this just shows that he's staying at a displacement of 30 the whole time. At time 0, he's 30 meters away from home. At time 5, he's 30 meters away from home. Time 10, 30 meters away from home. Time 20, 30 meters away from home. The whole time he's 30 meters away from home. That just means he's not moving at all. His speed is 0. So how do we represent this? Now we said before that speed on this graph is shown by the slope or the gradient. So if we have a constant speed, what must we have? We must actually have a straight line. That's what has constant gradient. The gradient is not changing. If you want a changing gradient, you need some sort of curvy thing. That's where you have to draw a tangent to see the gradient. But if you want a constant gradient, it's got to be a straight line. So that tells us our graph is going to have a part that's a straight line. So what else do we know? He's heading north, so he must be going in this upward direction. Now we can just draw the graph. So constant speed should be a straight line, like that, something like that. So he starts out right at home, and then he ends up at 30 meters away from home, and it takes him 10 seconds. And that's how you would do that. That's how you draw the first graph. It's quite easy. Yeah, that's the key idea. Remember that the gradient shows the velocity, yeah, on this graph. Then we can try out another question right now. Okay, so now we can try out another question and see what that looks like. Jenny is 30 meters north of home and walks at a constant speed of 1.5 meters per second until she reaches home. Let's use a colored pen. Let's see. There we go. Oh yeah, we need to extend this once, like that, something like that. Now I've drawn the positive part a lot bigger. Okay, now how would we do this? So this is our displacement in meters, and we said the positive part is north. We decided to take it like that, but you could also do it in reverse. It would be just as fine. There'd be no problem with doing it in reverse. So she walks at a constant speed of 1.5 until she reaches home. So she's 30 meters north of home. So where will that be? North is up here, and then 30 meters will be somewhere there. So this is 30 meters. And if she reaches home, what does that mean? Home, we said, is zero displacement. We're measuring from home. So you're back home. That means you're 0 meters away from your home. So she needs to come back somewhere here after some time. So she's starting at 30 and she's heading back home. Constant speed means the gradient should be constant. So a straight line. Draw a straight line until she reaches home. Something like that. And then we need to figure out how long does it take her to get home. So that. So the displacement, the distance she needs to cover is 30. Her constant speed is 1.5, and constant means acceleration is 0. Anything else we need? No, we need to find the time now so that we can label that part. So let's use S equals UT plus a half AT squared. This is quite a commonly used formula when you're working with your graphs. So then we'll have S, which is 30. Let's just remove this. 30 is equal to 1.5 t plus a half. What's the acceleration? 0, because constant speed. And then t squared. Well, a half times 0 times t squared, 0 times anything, we'll just remove it completely. This will turn into a 0, so we can as well remove that. So we have 30 is equal to 1.5t. So we need to divide through by 1.5, divide this by 1.5. And 30 divided by 1.5, t should be equal to 20. So the time here is going to be 20